You're listening to Behind the Wheels with Doug Mason, Dave Walters, and Mike Yeagley. This is a show where we talk about heavy truck and medium-duty axolans. Doug, Dave, and Mike bring close to 100 years of experience and expertise in the transportation business. Join us once a month to learn new things about axolans. Sponsored by Alcoa Wheels, the global leader in aluminum wheel innovation.
Welcome to another episode of Behind the Wheels. I'm Mike Yeagley.
I'm Doug Mason.
I'm Dave Walters.
So we always have a little fun with this. This is another Wheels of Shame, which is an episode we do occasionally. I think we did one before. And these are just wheels that we get in through our warranty center that have been just badly abused. And we actually hold on to them as educational examples that we show the engineers, we show the salespeople. And now we're going to be sharing them with you. We're going to be trying to describe what we're looking at. It's helpful, very helpful, to visually see what we're talking about here. We're going to do our best to describe it clearly, but always the picture's worth 1,000 words. And so we're going to be having these pictures in the show notes. You know, if you want to see what we're talking about, go onto the website, take a look, and you'll see these wheels, which are just I'll tell you, they're surprising how badly they've been abused. Dave, I'm gonna let you try and explain this first one. What are we looking at here? Try and describe it. I guess we'll start out with that.
Okay, basically on a wheel, this is flat, like a big flat spot. And what happened to this wheel, it's a wide base, and it had a tire blowout. You know, you blow out a tire, the first thing you start to think about is hitting the brakes. Well, when you hit the brakes and you don't leave up on the brakes, you're dragging that tire along the pavement as you're trying to get the truck to stop. And basically, it got really hot and it took away a bunch of metals, so there's a humongous flat spot. And when the guy called us, his comment was, yeah, I blew out a tire, and yeah, I hit the brakes, but it's got to be soft metal. That's their favorite comment, to always tell you it's got to be soft metal. And being in the aluminum wheel business for the past 32 years, and then when you explain to them the heat treat process and all the bells and whistles that we put into making these, it is not soft metal. So it's a very interesting one to see how hot a wheel can get in a very short time when you're hitting the brakes and running it across pavement.
What it reminds me of, Dave, is if you want to visualize this, you get a huge chunk of sandpaper and a circular piece of wood, and you start sanding that, and just how you can remove the material so fast. Basically, I would imagine this is probably on an asphalt road where they did this, and it looks like it was just sanded right off. I mean, when you get a chance to look at the pictures, if you guys go on to the notes, you'll see that this is like about a 9-inch section of the wheel that's removed. The flange is just gone. So yeah, it's very impressive to see. And obviously, if it was a soft wheel previously, it would have deformed and not have been removed like this here.
When folks are saying that they're dealing with a soft wheel, what they're talking about, they may not even know they're talking about this, but what happens is, like Dave was saying, our heat treat process, we call it the T6. That T6 is the recipe for heat treating. And what that does is that's what hardens the wheel. That's what really gives the wheel its strength. And when somebody says that they've got a soft wheel, what they're trying to say is that, hey, you guys didn't heat treat this wheel properly. The metal is soft. It's not strong like it's supposed to be. If there is a soft wheel out in the marketplace, which, thank God that doesn't happen, the heat is what does that. We've had some shows on small wheels, and really small wheels are soft wheels. What happens is you heat up the metal, and then the metal gets soft. It loses that T6 heat treat. What can happen is that the wheel will start shrinking on the open end, and the wheel is soft. It just starts shrinking a little bit on the open end and won't be able to hold the tire properly. If you drag a wheel with a load on it, like If you drag a wheel with a load on it over asphalt and it looks like this, that is not a soft wheel. That is a wheel that's being ground down to nothing. And that's exactly what this looks like. I guess that before somebody goes and starts talking soft wheel, you really need to understand what a soft wheel is. Soft wheel comes about because of heat. And this is a mechanical damage that we're looking at here.
Just to say, yeah, you're just going to get deformation if it's a soft wheel. If you've overheated the wheel in some way, like you said, it's just going to deform. It's not going to be removed like you've seen.
Right. Hey, Dave, how should he have handled this? I mean, he's going down the road. He has a blowout. The tire blew out, so there's no reason that the wheel should have been destroyed. He slams on the brake. What's the right thing for a driver to do?
Well, unfortunately, with wide base, now this is a wide base wheel. If you have a blowout, and this is one of the things that a lot of companies don't like about wide base, when you have a blowout with a wide base, that wheel's going to hit the ground and you're going to ruin the wheel. A lot of these guys used to tell me road calls are extremely expensive, but you're not only buying a tire, which a wide base tire could be $1,200 to $1,500. You're buying a wheel, you're doing a road call. I mean, it's very expensive with the wide base. Now, the benefit, of course, the wide base is hauling more payload. So, but on a wide base, that happens. Now, a lot of times what you see, this driver was on the brakes hot and heavy. A lot of them will hit the brake and then let up a little bit and hit it again. It's just really their training. So you might see two flat spots on a wheel and you're saying, well, he hit his brakes once and then he hit them again. And you know what I mean? But on a wide base, unfortunately, you're going to do that. Now on a set of duals, because you have two tires and you have a blowout, say on the outer dual, the chances of hitting the asphalt is slim to none because you still have the other one and vice versa. So duals, you don't hit asphalts. Wide base, you definitely hit asphalt.
Okay. Let's move on to the next one. Doug, why don't you take a shot at this one?
Well, this one really is interesting from the standpoint of how much deformation we're seeing here. If you can think of the, one of our dual wheels and you have the open end, you typically would see a nice round surface. Well, think about going around that outer rim and all of a sudden you have a tremendous dip in towards the hub. And then continue on around the wheel. And this really is from a real heavy impact situation where the flange has been bent dramatically, and would presume that they would have had air loss on this situation as well. And so this is just the amount of force in what they would have run over or hit. Not exactly sure. It looks like it only hit the flange, the open end flange. It doesn't look like it hit the inboard flange from the picture. So that would be what you would describe this as, is just a large deformation that caused a unseating of the bead of the tire and created a flat.
So the only reason we have these wheels is because these customers sent them to us thinking that, well, maybe they would get a warranty return, that we would accept them as a warranty return, that it's somehow our fault that the wheel is damaged. Dave, do you have any background on this particular wheel? Do you recall this particular?
Yes. And the reason I kept this one, because either I talked to the customer personally when we reject it or one of my people do. So, but this one was probably the most funniest conversation I had. I called the guy and I said, we're not going to warranty this because it was an impact hit. And he says, well, I hit a moose. And I'm like, you hit a moose? He said, yeah. But I missed it with my front. I only hit it with my duals. And I don't think a moose could bend that wheel like that. And I'm like, a moose is like hitting something bigger than a horse. And, we definitely don't warranty against mooses. You know what I mean? Like, that's not a warrantable. And he's like, well, I guess if you don't warranty hitting mooses, I guess I can't have an argument. But I still think that's what he hit, was a moose. And he was so... didn't hit it with his front, but he got it with his duals, you know what I mean? And he's like, it wasn't that big a moose. And I'm like, well, any moose is unwarrantable to us. So you're sorry, mooses don't count. Horses, cows, you know what I mean? Like, certain animals you hit, no. So That's what he hit, was a moose.
Wow, that
I
tells
had
you
to keep that.
how tough a moose is. That's for sure.
That's what moose damage looks like.
Oh,
That's a big moose.
That's
oh, that's funny. Let's move on then. And I guess this one is also very interesting because it's a picture of an aluminum wheel and a steel wheel dual, with the steel wheel not looking so good. And Dave, I know that you really gave me some good insight when we first looked at this. So I'm going to turn this over to you again as to what happened here.
I don't like the steel inner and aluminum outer. I know a lot of people run steel inners and aluminum outers. And this is what I'll tell in my story when I would go out and do training programs. Steel wheel flex rate compared to aluminums are totally different. Steel wheel flexes a lot more. They're thinner. They're not as strong as a forged aluminum wheel. So what you have is you got two different flex weights. So even at the same air pressure, you got different flex weight. Then you put a steel wheel on the inside where it's harder to get to the valve stem, especially when you're running an aluminum wheel to get to the valve stem. And say you don't have the right air pressure, one of those wheels is flexing a lot and the other one isn't. So when the steel wheel breaks out, it breaks out. I mean, completely, this one's got chunks missing of it and it breaks apart. And not only are you ruining your wheel on the inside, you're probably going to ruin your wheel on the outside. And a lot of times you can even ruin a tire or a brake drum. So steel wheels and aluminum outers is not an application if you're, and I'll put an asterisk between this here, but if you're hauling very light loads, and I mean light loads like fiberglass or something like that, that you're not hauling, your max load's maybe 15,000 pounds, you might be able to get away with it. But boy, if you're hauling 80,000 pounds of steel inner and aluminum outer, it's going to cause you problems down the road. So anyways, that's what this picture is.
So basically what's happened here is you have the ongoing flex, and you have just a hell of a lot of flex of that inner steel dual, and it just looks like it broke into pieces. There's nothing left of the mounting flange that I can see. It looks like it
there might
completely
be
broke off.
a little bit holding the aluminum wheel in position from the inner of the bolt circle, or along the bolt circle, is kind of what I see. And so they're fortunate actually that is still there, or the outer would be wobbling all over the place.
Most of the time, the whole center breaks out of a steel wheel, and then it starts flopping around, and that destroys the aluminum outer, and it can even get the tire and can even get the brake drum. People always say, steel inner and aluminum outer, the flex rates are so greatly different. I mean, aluminum wheel, the thicknesses we make on an aluminum wheel, a forged aluminum wheel, there is no flex, where steel wheels are tremendously flexing as they go down the road.
Right. That makes a lot of sense. It's just for our listeners' knowledge. An aluminum wheel will, and the mounting flange will be typically about twice as thick, maybe a little bit more, maybe a little bit less. But in the handhole area and the disc face there, it gets real thick compared to a steel wheel. And in this picture, you can see the wheel thicknesses. You can easily see the wheel thickness of the steel wheel and compare that to the aluminum wheel, and you'll see it looks like 2 or 3 times the thickness, at least from this angle. The aluminum wheel is like 2 to 3 times the thickness of that steel wheel. And although steel is strong, the mechanical properties of steel are certainly strong. There's sometimes that thickness is, especially when you talk about stiffness, nothing helps like just having thickness there, having that mass, or having the I would say the dimensional thickness is what really stiffens things up. And like Dave has said, you will see a big difference between the two. And this is the first time I've seen this picture, Dave. And I guess this is sort of unusual. Usually we just see wheels. We usually don't see this is a picture. You can see the aluminum outer and the steel inner, and you can also see the brake drum, and it's all on the hub. I mean, it's still part of an assembly. This looks like you guys went out to the shop and actually took this picture. My guess is they didn't send this in to us all as an assembly like this.
No, this is one that I went out to a shop and the guy's showing me what happened. So I got a picture of it. And my comment when I would go out to training classes after that, I would share this photo saying, hey, fuel inners and aluminum outers, this is what can happen because of the flex rates. And so it was a good tool just to have that picture. And, I used to kind of kid everybody. I'm like, well, I'll be honest, my son actually said it. It's like, you've been to every state, you've been to every continent except Antarctica to look at wheels, and it's amazing that they would send you all around. And I'm like, yeah, I've been a lot of places. So a lot of times when these photo ops come up, I love to take a picture and say, wow, this could be handy sometime in the training session. It's a good one.
Okay. I'll try and explain this one. Basically, this is a stylized wheel. And when we say stylized wheels, typically our wheels have just round handholds. And this one has handholds that have some shape to them. It's elongated handholds. That's how it's designed. So the wheel has these longer handholds, and then what looks like has happened is the wheel broke from handhole to handhole. So there's a crack that went from one handhole to the next handhole. And I guess from an engineering standpoint, I find it interesting the way it cracked. It cracks down toward the hub and then goes back up toward the next handhole and then down towards the hub, sort of making a zigzag shape as it works its way around the wheel. It looks like the photo only shows like 4 or 5 handholds here, but it looks like the entire mounting section of the wheel is removable now that it's been broken 360 degrees all the way around. So Dave, any stories behind this one?
Oh, absolutely. Like I said, I only ever kept wheels that I really found a great story. This is actually from a coal hauler. And this coal hauler, I really don't want to mention the state, but in this state, they were very brazen about overload. And the one time I was down there and he had this wheel and, I'm like, wow, the loads that you're carrying. And he's like, no, I'm really doing a good job. I'm cutting my guys back. And I says, well, what do you mean you're cutting your guys back? He says, cutting them back to 90 tons. I said, 90 tons? Yeah, back to 90 tons. Anything over 90, I'm not paying them for no more. You know what I mean?
Oh.
And I'm thinking of the whole tractor trailer. He's talking about just the load. You know what I mean? The legal payload's 23 tons. You can't make no damn money at 23 tons is what he said to me. So I'm like, oh boy, here we go. And I'm like, I think you need severe service wheels and there still won't be any warranty. And you know what I mean? But needless to say, the DOTs of the state now don't allow that kind of stuff to happen anymore. But this is off a coal truck. And if you look at the wheel on the photo, it's as dirty as you've ever seen and smashed. And we always say poor inspection protocol. You know what I mean?
Well, yeah, to allow it to get that far. But it brings up a very good point about just overload in the design of the wheels themselves. I mean, these are designed very, very carefully. And there's a lot of technology that goes into them, a lot of accelerated testing at high loads to ensure there's a margin of safety. And so, like you said, Dave, you go out and you take a look at these things and you know that the wheel is designed to handle the load the vehicle is rated to, the axles are rated to, the tires, everything, the whole system together. And I'm presuming that if they're having issues like this with the wheel, they're probably having issues with other portions of the whole suspension as well. That's a tremendous overload.
Their tire life is next to nothing. They go through brake drums and brake shoes because they're trying to stop these. But all they're trying to do, and I really appreciate American ingenuity, it's about how much coal could you run across the scale. And if they legally ran that, like the one guy said, it's like 4 to 1. I'm getting 4 loads for 1. So you add up the math and see what happens. I'm not going to argue that with you. I'm just saying from my standpoint, no, you ain't going to get no more warranty. The best we got, severe service, you still won't get no warranty. But you got to understand like Doug said, load is critical, and you can't overload a vehicle like that and expect durability out of any of your products.
You know, it reminds me, Dave, you and I spent some time in China together. Some of those high load guys that we met there were just unbelievable. And basically what they did there was they just had throwaway vehicles. They would buy a vehicle, they'd have it for a year, overload, just amazing overloads. They just would calculate, I can carry 10 metric ton per wheel. And so if this vehicle has 10 wheels, well, then I get to carry 100 metric ton. And don't forget, a metric ton is 10% bigger than a US ton. So they're looking at like, oh, I can carry 110 tons. Or, you know, if they had, you know, we'd see 15, 20 wheels on the vehicle. Oh, I can carry 200 tons, 200 metric tons, 220 American tons. And I'd ask them, so, you know, what kind of, you know, what do you do with these vehicles? How's it? They last for 6 months and I throw them away. It's a completely different world when you get into these high overload businesses. Like you said, those coal guys, they do the math. They know what the damage is to the vehicles, and they sort of run with it. But it's that's amazing. I guess I didn't realize we saw that to that level here in the U.S. also. That's 90 ton is just an amazing number.
Now, again, I'll say this is going back because that state now has basically told them Holland Coal is allowed to run 100,000 pounds vehicle coal, everything from 180,000 pound payload plus another 25, 30,000 in vehicle, 210s, 220s. So now they're down to 100. So we're going in the right direction, but we do make severe service wheels, and I always stress that.
So let's go to the next one. Dave, what's going on here?
Okay, this particular one, if you can see, the wheel actually cracked the whole bolt circle. And this is another designer wheel. We don't know what the inner dual did, but we can tell you that this wheel was moving. We believe the inner dual could have been a steel wheel and basically gouged out or, you know, smoothed up the other part of this wheel. But this is one I really didn't talk to, but whenever we got it in, it was unique because the mounting flange is still intact and the other part of it is not. And to me, this looks like they were running a steel wheel, inner wheel, and it broke. And when it did, it just carved up everything that it could except the mounting flange. But it also cracked our wheels. So when we say poor inspection protocol, this is kind of the poster child.
Yeah, it's very, if you can get on the show and look at this, it's very unique. The inner mounting circle basically stayed stationary. So that would, in my mind, mean that the inner wheel, steel or otherwise, had to break off just outside of the bolt circle. And as you said, tore up the other wheel and ended up creating this crack that went around. But it stayed in place. This thing had good torque on the nuts.
Yeah. So
it stayed.
Try to explain this a little bit more. It's got, like the other guys have said, we call it the bolt circle. And the bolt circle is if you take a line, make a circle that goes from bolt hole to bolt hole to bolt hole to bolt hole. That is called the bolt circle, and that's part of the design geometry. It's how we know that our wheels are going to fit nicely onto the hub. So we pay a lot of attention to the bolt circle, and what you've got here is all the metal on the inside of the bolt circle from the bolt circle into the hub is perfectly in great shape. There's nothing wrong with it, but going out from the bolt circle out toward the rim, it's just tore up. There's a crack that goes 360 degrees around the wheel at the bolt circle, going from bolt hole to bolt hole. And then on the mounting face there, the part that's been beat up, it looks like it's been dragged along something. It's another one that has that same sandpaper look to it. There was certainly movement on the inner dual. Something was moving around there, or and just beaten up that wheel on that surface, and it is a steel wheel that didn't make it. It's the best conjecture, best explanation I can think of. Or I agree with what Dave's saying. That makes the most sense. It's amazing the kind of damage that we're seeing on this thing.
And the fact that the wheel stayed on the vehicle.
Yeah, they were at 500 foot-pounds, so we've had a lot of discussions on the benefits of keeping within spec. At least they did that right. Well, that does it for today's episode of Behind the Wheels. Really glad you joined us. I had a lot of fun with this one. If you want to get in touch with us, you can go to the website at alcoawheels.com. Click through. There'll be a selection there to go to the podcast, and you can write us any questions or comments, and we'd love to hear from you. I think that does it. Thanks a lot. We'll see you next time.
Sponsored by Alcoa Wheels, the global leader in aluminum wheel innovation, manufacturing, and technology. Inventing the first forged aluminum wheel in 1948, its team of experts continue to develop the most lightweight, efficient, and high-performing commercial vehicle aluminum wheel products. Bringing you revolutionary innovations like Alcoa DuraBrite wheels, Alcoa DuraBlack wheels, the new Alcoa Wheels hubboard technology, and the lightest truck wheel on the market, Alcoa Ultra One 22.5 by 8.25 wheel. Alcoa Wheels, the global leader in aluminum wheel innovation.